Hey, this is Mr. Baxter here. We're going to take a look at the last section in Chapter 3, which means we have a test this Friday. But you're going to take a quiz first on this section, Section 3-5. We're proving lines parallel, so it's pretty easy stuff. You need to definitely be familiar with your consecutive interior, all these guys right here. So here is your little warm-up. If you want to try it out first, hit pause right now. All right, hopefully you hit pause. Consecutive interior angles, those are the ones on the inside on the same side. So your consecutive interior would be angles 2 and angles 5 and angles 3 and angle 8. Those are both on the inside, same side. Okay, remember, these are the two lines that are this is your transversal. So M is your transversal. Don't forget, transversal. Something just fell in the kitchen. So that's your transversal. Corresponding angles, one outside, one inside. So corresponding would be like angle 1 and angle 5, angle 2, angle 6, angle 4, angle 8, and angle 3 and angle 7. Alternate exterior, they're on different sides of the transversal, and they're on the outside. So alternate exterior are these guys, they're on the outside. So that'd be like angle 1 and angle 7 and angle 4 and angle 6. So there's a little review for you. Again, you can go back and watch that again if you want. Oh, if the table bounces, look at that. All right. Okay, so here we go. You need to determine, given values, you need to determine whether the lines are parallel. So you have parallel lines if your corresponding angles are congruent, if your corresponding angles, alternate exterior angles, alternate interior angles, and if those guys are congruent, there's your congruency. If those guys are congruent, then they are parallel. The two lines are parallel. If your consecutive interior angles are supplementary, remember that's your 180 degrees, then the two lines are also parallel. So you're just looking at the values you got. The first thing you got to identify here, and whether you know this or not, we're definitely going to be hitting a lot of triangle stuff coming up. You have a triangle here. So that is a triangle. How many degrees are in every triangle? Every triangle, all the angles, you add them up, they equal 180 degrees in a triangle. So if that's 45, that's 65. That's a total of 110, which leaves me with how many degrees left for this angle here, which would be 70. So this angle is 70. So we're going to work off of that. If that angle's 70 right there, and this angle's 70, that means, they just dropped something in the kitchen again. That means that these two corresponding angles are congruent, which means the lines DF is parallel to GH. And then we can determine up here, it says to figure out whether AB is parallel to any of these guys, it says BG bisects ABH. So this line, BG bisects ABH. So if that's ABH, so if that's 45, this side is 45. So if that's 45 and this side's 45, and then these are alternate interior angles, are those congruent? And the answer is no. One's 45, one's 70. So AB is not parallel to anything. To either DF or GH. Okay. Again, you can watch that over. I think you're going to find this a little easier down here. Given angle 2 is congruent to 8. So where's 2? Here's 2. Congruent to 8. Okay. Determine which lines are parallel, which lines, if any, are parallel. State the postulator theorem. So basically, tell me why. So here's 2, here's 8. They're congruent. I can tell they're alternate interior angles. So that's your reason. Alternate interior angles. It's this angle and that angle. Has nothing to do with these guys down here, so I'm not even paying attention to them. They're out. This is my transversal. L is my transversal, so that means that A has to be parallel to B. So A is parallel to B. Simple as that. Yeah, we're going to involve some algebra here. So you're given some values here for this angle and that angle, and if these lines are to be parallel, these angles would have to be equal to each other. Those are corresponding angles. So we can set those equal to each other. 8x plus 4 equals 9x minus 11. Solve for x, and then put it back in. So whatever x equals, you put it back in to figure out RSU. We've done plenty of algebra now that you can do that problem, figure out x, and put it back in. Other side. This problem up here, it's a little yucky actually. So you got this angle and this angle, and they have no relationship, but we can figure out what's going on. So if this angle is 9x minus 5, this angle over here also has to be 9x minus 5, alternate interior angles, and then these two have to add up. They're not equal. They have to add up to equal 180 degrees. So there's your setup. 7x plus 3 plus 9x minus 5 has to equal 180 degrees. I can tell you right now, when you solve for x, you're going to get a yucky answer. That's like a decimal, 11 point something. Yeah. So when you do all your work, like x equals 11.375, and then you would just put that back in to figure out what JKM is. Quick, I'm not really worried about this problem over here with the fractions. For right now, determine if these lines are parallel. Well, you would just look at their slopes, correct? So remember, parallel lines have the same slope. So to do that, I could just do rise over run. To get from here to there, I would have to go up 1, 2, 3, 4. I went up 4, and I'm right here, and now I'm going to run 1, 2, 3. So I have a slope of 4/3 for that line, and then to get from here to here, I'm going to have to go up 1, 2, 3, 4, and then I'm right here, so I'm going to have to run 1, 2, 3. So they have the same slope, so those lines are parallel. Make sure you do the practice problems that are assigned in class today, and we'll talk about everything. Peace out. Yo.